Hey guys, welcome to the Rusty Beauties shop again on the Rusty Beauties YouTube channel. In this video I want to talk a little bit about our old cars, tuning up or even diagnosing our engines using a little bit more modern ways, not just our ears, eyes, or in the best case scenario a strobe light. Isn't there a better way to do that? Maybe there is. As you may know, nowadays on the modern cars you have an OBD2 port where you can just plug in a scanner and you can see everything about your engine, starting from the RPM and finishing with the amount of carbon in the exhaust gases, for example, and stuff like that. And even for not so complicated problems, for just reading the codes that your ECU generates in your car, you can even plug in your phone. Like there's a device that you plug in your OBD2 port and then connect to your phone, and you can observe on your phone and it can tell you there's a P031 code, for example, which means that your O2 sensor bank 2 is not working. So there's lots of information that you can extract from your modern car. But how do we do that with these cars? You know, I'm working on cars that are from the 60s and 70s, and hopefully soon I'm going to be working on a car that is from the 50s. So at that time there were no OBD2 ports, there was no anything. In the best case scenario, we can use a strobe light on the crankshaft pulley and see how many degrees our timing is set at that particular moment. That's all. Now actually I think there is a possibility for us to start diagnosing and tuning up our old engines a little bit better. I'm talking about here in my garage. Can I do something like that? Maybe I can. Let's see. Well, I gave you a little teaser about that. I don't know if you got the hint in my previous video, but I have a set of wires here that my friend Eugene gave me. So he's a friend of mine who keeps giving me more and more and more tools. I don't know how to thank him enough. Thank you, Eugene. So now he gave me something that I can use to diagnose and tune the engines of these old cars. So what it is, it's a set of wires. So as you can see, I can hook up many wires here to the engine, and then I can extract information with them. So let's see how we're going to hook up those wires. So first of all, we need a signal from the coil high voltage wire. So we're going to put this clamp here on the high voltage wire that comes out of the coil. So we need a signal from the high voltage wire on the first cylinder, or the spark plug wire on the first cylinder, only on the first, nothing more than that. This one says alternator, positive. So we're going to plug this one to our battery. That can give us a signal of the positive side of the battery. How does the alternator charge? We have a negative. We're going to connect this to the negative side of the battery. And then we have this primary. Oh, okay. So we need to connect this to the primary circuit of our coil. And we're going to talk about that later, about primary and secondary ignition systems. If you're familiar with that, great. If you're not, I'm going to explain to you. So we're going to connect this to the negative of our ignition coil, the negative side. And then on this side, we're going to put this clamp on the starter wire, the big, heavy-duty starter wire. And we're going to connect it here, like this. Well, that's great. Now everything is hooked up on this side, but what do we do with the other end? It's just hanging here. And I want to plug it into something like my iPad, for example. And if I plug it into my iPad, I'm going to be able to observe the information that I have from the engine, because the information is here. We just need an adapter for here. And as you may have guessed, Eugene gave me the adapter as well. So we can plug this into the adapter, and this way we're going to have the information that we need on the screen of the iPad. Yeah, believe me, it's possible. All right, so right here at the back of this adapter, we have the same plug. the female part of it. So we just need to plug in this here. Turn the nut. There you go. So the adapter is plugged in. And now let's see on my iPad if we can bring the information that we need. That's funny. There you go. It works. I brought the information to my screen. I can see the secondary waveform here on my iPad. Alright guys, happy April Fool's Day. I was kind of kidding, but I was actually able to bring the information to my iPad, wasn't I? Anyways, let me introduce my new best friend in the garage. Snap-on Canceller 2. Let me turn off the car and we'll talk a little bit more about it. Alright guys, as you can see, this is a piece of very old equipment, but with these old cars, like I said, where you don't have an OBD2 port to plug in, this is actually something that is great help, that you can actually see in digital format what your engine is doing. So, like I said, my friend Eugene gave it to me to use it. He didn't give it, he gave it to me to use it, but I can use it for all these cars to diagnose and to tune up even. So I'm assuming that many of you know exactly what these things do, the scopes, when you connect them to the engine, but I'm also assuming that many of you, maybe the bigger part of you, are like me, who don't know exactly how a scope works and what information it can give you. I'm saying like me because until recently, like 2-3 days ago, I didn't know anything about it. But ever since my friend gave it to me, I hooked it up to the car and I got obsessed with it. I can't stop watching videos about waveforms, about cylinder tests, and about all the things that you can do with this. The thing is, it gives you all kinds of information. You have to learn how to use it though. I mean, how to use the information that you can obtain. There are many tests, we're gonna go through them, that can help you observe what's happening with your spark plugs, with your primary ignition system, with your secondary ignition system. You can observe the vacuum build up into the intake manifold and all kinds of numbers. We will go through them. But again, if you don't know how to analyze that, when I plugged it in, I saw that, I went through all the different menus here. I saw all the information. I didn't know what to do with it though. How was I supposed to use that information? Well, that's where the manual comes handy, because this manual can give you a lot of information about how to use the tool, but also gives you information about how to analyze the information once you get it. So let's hook it up to the car and we're gonna go through the menus. First of all, I wanna show you what information you can get, and then if you're interested, we can go into more details about each and every screen that we can see here. Maybe not in one video, maybe in more videos, only if you're interested, guys, because I am personally hooked up. I can't stop doing that. So without further ado, let's start the car and go through not all, but maybe the most important screens and the information that you can obtain with this tool. Fantastic tool, I'm telling you. It's from 1990s, but I love it. Okay, so first I'm gonna start the engine. And I'm gonna start the tool. And this is our main menu. So here we need to enter the engine data. So it asks you how many cylinders. You can go up to 16 cylinders apparently. So if you say 16 cylinders, you need to give it the firing order of 16 cylinders. Well, I'm just kidding. Yeah, we're gonna go back and enter 4 because we have 4 cylinders. How many cycles or how many strokes? It's a 4-stroke engine, so we keep it at 4. And then we need to provide the firing order, which for this car is 1, 3, 4, 2. And then enter. And now we are ready to start diagnosing. We have to enter the date and time and everything. So if we want to print anything, there's a printer even. We can print the results of our tests if we want to. But we're not going to use the printer. Nowadays we can take pictures of the screen if we want to. Again, we're not going to go into details about every test. I'm just going to give you what tests are available. So as you know, the ignition system is divided by two, primary and secondary ignition system. We can test them separately. If we go primary menu, this is the primary ignition system, and it gives us three different tests here. One is duty cycle bar graph, that's in case you have injection system, electrical injection system, because there's also mechanical electrical system like on the PITR6 for example. Well, that won't work here. So it gives you the duty cycle of the injector, and it can also give you the voltage of the injector. We don't have injectors here, so it doesn't tell you much. So we're gonna go back. The second test of this primary menu is the dwell bar graph. So the dwell is the time of your points. For example, in this case we have electronic ignition, but if we have a points car, let's talk about points because it's easier to explain. The dwell time is the time between your points close and the points open. So that's the amount of time they stay closed. So if we go to the dwell bar graph, it tells you about each cylinder how long the points are staying closed. It tells you in percent or in degrees on the camshaft. These are camshaft degrees. So the points are closed here for 50 degrees on the camshaft. So that's the other information. Or we can observe the primary waveform, which is the most valuable information. So you can see this is for cylinder 1, this is the waveform of what's happening in the primary ignition circuit. We're going to talk more about that. You can also check the cylinder number 2, cylinder number 3, cylinder number 4, or you can have them in parade if you want. So it shows you all four at the same time so you can compare them, all four cylinders. You can also adjust the size of the waveform, you can go back and forth, you can turn on a grid so you can measure. So these are the three different tests that you can do on the primary ignition system. Then we can go to the secondary ignition system and we can do pretty much the same. I'm actually going to go backwards on the test here so we can observe the secondary system waveform, which is pretty similar to the primary waveform, but here this one is much bigger scale. The primary ignition system is the low voltage, this is the high voltage. Here we get to 18, 20 kilovolts sometimes, so that's the difference. So that's the waveform, but this waveform also has different sections here that we can observe. So this is the dwell section, this is the firing section, and this is the intermediate section. So we can go back into the secondary wave menu and we can see the firing section, how long it is. So this is called burn time. This shows you how long is your spark, how long in time your spark is sustained. So here it shows you that it is sustained for about 1.5 milliseconds. From the moment the spark is ignited to the moment it's extinguished, for each cylinder this is 1.5 millisecond. This is the minimum time observed during this test. This is the maximum time observed. If you clear it, these are going to start again. So you can see here the minimum is this, the maximum is this, but the minimum goes lower and lower as it is observed, and the maximum goes higher and higher as it is observed. And here it gives you a bar graph even of the burn time. So this is only how long a spark plug is sustained. So this is only this time from here to here, but we're gonna go into details later. That's 1.5 milliseconds. Also, this waveform shows you the build up in the coil. That's how high the voltage can be in the coil. That's this number here, kV. It stands for kilovolts. So this here goes up to 16, 18, 17 kilovolts. But you can also observe that here in this test. So kV bar graph, this tells you for each cylinder now, it's collecting data. Now it's going out of the screen so we can change the range. Now this is a better size for this. It shows you for each cylinder how much does the coil build up. You can see here cylinder number 3 builds up to a lower kilovolt, lower level of the voltage, and we're going to deal with that later. So again, it gives you the minimum, the maximum, and the current kilovolts built. And you can also see this information in a histograph. So now here it shows you 256 consecutive, again the range is wrong, so 256 consecutive firings, how high it built up. So that's cylinder number 4, that's cylinder number 1, number 3 you see it's much lower than the other ones, but in each firing it shows you how high the coil built up before it fired. So that's another information, and that I believe are all the tests that you can perform for the secondary ignition system. What else you can do is you can diagnose all the rest of your electrical components in the car, except the ignition. For the ignition we have the primary and secondary, but here now that's for the rest of the car. So for example, first of all you can see how your alternator performs. You can see the waveform of the electricity going up and down. So that's pretty good, nice and consistent. That's it's charging with 4.4 volts. It's charging with 4.4 volts currently, the alternator, and this is the waveform of your current. So that's one of the tests. Then if you have a fuel injection system, of course, again, you can check the waveform. Lab scope, this I'm not really sure how to use yet. Volt range, volt time, this I can't say much about this screen, but it is available. And voltage waveform, you can actually test different devices inside your car that are connected to your electrical. I don't know much about this. The next menu is your cylinder test. So this is a vacuum waveform. This shows you, if you hook up, there's a probe that comes with the scope that you can hook up to your manifold, and here supposedly it's going to show you the vacuum waveform, how you create a vacuum, then how you go high in pressure, and it shows you the waveform. But this car, as you may know, doesn't have a vacuum port on the manifold, so I can't hook it up. What else is in the cylinder test menu other than the vacuum? You can see the cylinder time balance. That I'm not really sure how to use yet, so again I can't talk much about it. Range selector, it's increased range. So this is apparently a time between the firings for each cylinder, which doesn't make sense to me yet. I'm gonna have to figure it out, but this is 31 milliseconds before each firing on each cylinder. And these are the differences or the variations out of the zero line, the average, let's say. So this is, I don't know how it's possible, the cylinders to vary in timing between each other, but again, we're gonna figure that out. This is interesting. This is cylinder shorting bar graph. So here you can kill a cylinder, a single cylinder, and see how much the RPM is gonna drop without this cylinder. So I don't know how the thing does it, but for example, cylinder 1, if I press 1, for example, and I hold it, this kills the cylinder number 1. There you go. So now we are running only on 3 cylinders, and this is the RPM drop. If I let go, that's what happened. I held it for 5 seconds, and in these 5 seconds, the engine dropped by 246 RPM. So that shows you how much this cylinder contributes to the amount of power the engine produces. So you can compare the 4 cylinders. You can actually clear that and do auto shortening. So in auto shortening, what the scope does, it kills the cylinder for 5 seconds, then it waits for a second and a half, I think, and then it kills another cylinder for 5 seconds. So it kills them for the exact same time, and then it shows you a comparison. So let's do that. So right now it killed cylinder number 1. We need to change the range so we can see it here. And the RPM dropped by 231. Now all the cylinders are running. Now it's gonna kill cylinder number 3 for 5 seconds. That's the RPM drop for cylinder number 3. You see how much different it is than cylinder number 1? Now it's gonna kill cylinder number 4. Then it's gonna wait for another second and a half, and now it's gonna kill cylinder number 2. So this tells you that cylinder 1, 2 and 4 are contributing to the work of the engine a lot more than cylinder number 3. So there's something wrong with cylinder number 3, and with these two we can diagnose it. So that's this test, and there's cranking amp bar graph. This is also an interesting test, so I'm gonna turn off the car for this test and we're gonna talk about it a little bit more. So for this test, the cranking amp bar graph, what it does, it kills all 4 cylinders. How does it kill them? I have no idea. But it manages to kill them. So it kills all 4 cylinders, and then it tells you to crank the engine. So you start cranking it, and in the beginning, as you're cranking it, it feels like it's going to start, but it won't start. So you crank it until the scope tells you, okay, that's enough, I collected all the information, or it actually allows all the cylinders to start, and when the engine starts, of course, you stop cranking it. But what it does is, during that cranking time, for approximately 10 seconds, it collects information for how many amps the starter motor draws during the compression stroke of each cylinder. It basically measures your compression. It doesn't tell you the PSI of each cylinder, but it tells you the relation between the cylinders. If you have one that has less compression than the other, this one is going to require much less amperage to overcome the compression, right? So if your amperage varies for all the cylinders, this means that you have different compression on all the cylinders. This means that your piston rings are bad on this cylinder, or your valves don't close properly on this cylinder, or something like that. So let's do that. I'm going to start the test and I'm going to go crank it. There you go. Wow, the battery of this car is not the best. Okay, I'm gonna turn it off now. So this is the information that it gathered during that cranking. So cylinder 1 required 133 amps in average to overcome the compression. Cylinder 3, 2, 4. You see, it is very, very consistent, because we know we measured the compression on this car, and it is about 180 psi. This also proves that it is very, very consistent, because the compression was 180 to 181 psi on all the cylinders. So, and these are all the tests, I believe. Everything else is options and memories and stuff, because you can memorize test results and put dates on them, or the information of the car that you want to memorize, whatever. You can also, during each and every test, for example, the waveform here, you can freeze a frame and then go and analyze it. If you want, you can print it and then you go and analyze it, or send it to a friend to analyze it for you and stuff like that. You can also set points of RPM, for example. During this test, you can observe the waveform, for example, while it is idling, but you can also set the point at 2000 and then another point at 2500 RPM, for example, and then you go and you snap it. And that's going to freeze a frame at exactly these 2 points, 2000 to 2500 or whatever. And then you can go and you can compare the waveforms between idling, 2000 and 2500, for example. So these are a lot of things that I have to still learn about this scope. I learned a lot about the primary and secondary waveforms, because that's very, very interesting for me, because I wanted to make sure that this car that I just rebuilt the engine, I wanted to make sure that everything is perfect with it. You know that I took a long time to make sure the whole ignition system has new components and it's working well. So now this proves that it works well. There's only one problem with the cylinder number 3, which I believe I know what it is. So maybe in the next video we're gonna go and start scanning the engine with the scope and finding out what the problems are. So anyways, that's going to be everything for this video. I just wanted to show you my new equipment in the garage. Again, it's not mine, but I'm going to use it for a while. And if you're curious about it, we'll see how the videos about this scope perform. if they attract interest, then I'm gonna make a lot more, because I can scan my Spitfire now, I can scan my Jeep, because I have some misfire on the Jeep and its injection system, so I'm gonna be able now to see if my injectors work well and stuff like that. I'm really excited about this, even though it's such an old piece of equipment, but believe me, I love it. I love it. We have a vintage car and we have a vintage piece of equipment to diagnose and tune our vintage car. So let me know what you think about that. If you're going to be interested to see more about it in the comments, and we're going to go from there. I'm definitely going to make one video about the ignition system of the TR4, and that's probably going to be the next video. So that's going to be it for today, guys. Thanks for watching, commenting, subscribing and sharing and supporting the channel, and I'll see you in the next one. Bye.